So we're moving on. We're going to learn about quadratic functions, and after today's video you will be able to find the zeros of a quadratic function. We're going to be able to see that in a graph and also find the axis of symmetry and the vertex of a parabola. So get ready to take some notes. All right, so we have learned that an x-intercept of a function is a value of x when y equals 0. Think about that. If I have an x-intercept on my graph somewhere over here, my y is equal to 0. So a 0 of a function is an x value that makes the function equal to 0. Remember that every point on the x-axis has a y value of 0. So anytime we're on this x-axis, my y value is going to be equal to 0. So we're going to be looking for zeros of a quadratic function. Let's take a look at some examples. Here I've got, remember, a quadratic is going to look like a parabola. And here I've got my parabola crossing my x-axis 2 times, so I have 2 zeros. Here my parabola is touching the x-axis, therefore I only have 1 0. And here my parabola is below my x-axis, so I have no zeros. So to find the zeros of the quadratic function, we are looking for the x-intercepts. So the question is, what are the zeros in the above graphs? Well, here I've got a 0 of 3 and -1. Here I've got a 0 of -4. And here I have no zeros. So when you look at the graph of a quadratic or a parabola, you can see the symmetry. So it looks the same on either side of this invisible line that divides the parabola into 2 halves, and we're going to call that the axis of symmetry. So the axis of symmetry, though, is always named as an equation. Here's an example. I've got an axis of symmetry. It's that line that's going to divide my parabola, so it is exactly equal on either side. That axis of symmetry hits right here on my x-axis at -3. So the equation for my axis of symmetry is x equals -3. So it is written as an equation. So we can find an axis of symmetry by looking for the zeros and then finding where it is halfway in between. So here I've got 2 zeros at 1 and at 4. So I've got 1 and 4, and I'm looking for the number that's halfway in between. So obviously I add those and divide by 2. So my axis of symmetry is 5 divided by 2, or 2.5. So my axis of symmetry is that x equals 5 halves, or 2.5. Here I've got a parabola that is tangent. Tangent means that it is touching. It is tangent to the x-axis at this point, -1. I only have 1 0, so that's exactly where my axis of symmetry is at that point where it is touching at -1. So my axis of symmetry here is x equals -1. This time, don't have a graph. So let's figure out what the axis of symmetry is. Well, I'm going to show you a shortcut for finding it. I've got my equation, y equals ax squared plus bx plus c, which is what I've got up here with specific numbers. My a here is 1. There's nothing in front of my x squared, so my a is 1. My b is the coefficient of the x term, or 8, and my c is the constant at the end, or 12. And I've got a formula for finding my axis of symmetry. My formula is x equals -b over 2a, and you're going to need to memorize this. So write that down big and bold. You need to memorize this. This is not on your formula chart. So to find my axis of symmetry, I've got x equals -b, and remember my b was 8, so negative 8 over 2 times a, which was 1, so over 2. So my axis of symmetry is x equals negative 4. So when I graph this parabola, which is what a quadratic will look like, I will find that my axis of symmetry is at x equals negative 4. The axis of symmetry, so I'm going to identify A, and my A is 1 again. Oops. And my B is 3. And remember, my formula is x equals negative b over 2a. So I've got x equals negative 3 over 2. And that's going to be my axis of symmetry. So you need to try this one. Pause your video very quickly, come up with your axis of symmetry. Okay, so you simplified it. The axis of symmetry was x equals negative 1/4. So now we want to find a vertex, and a vertex is going to be the point on the graph that is either the bottom or the top. So if I've got a parabola like this, my vertex is going to be the bottom. I may have one that looks like this. This is my vertex here at the top. The vertex is the minimum or maximum point. Okay, and I'm looking to find the axis of symmetry. So remember, this is the x value of the vertex. Then I'm going to find the y value of the vertex by substituting the x value into the equation. And we're going to try that right now. So the axis of symmetry, remember, is x equals negative b over 2a. So I've got x equals negative 18, so positive 18 over 2 times 3, or 6. So my axis of symmetry is at x equals 3. Now, to find the vertex, the y value of the vertex, I'm going to plug in that 3 into my equation. So finding my y, I'm going to plug in 3 for all of my x's. And I find that y equals negative 20. Okay? So the vertex I'm going to write as an ordered pair, and that ordered pair will be my x value of 3 and my y value of negative 20. And that will be my vertex. So this parabola, were I to graph it, would look like a smiley face. It is an upward, like this parabola. It is an upward facing parabola, and so my vertex was at the lowest point. So 3, negative 20 was the lowest point of the parabola, and it went up on either side from there. Okay, so I have 2 equations here, and I want you to find the vertex of these 2 equations. Pause your video and remember to find the axis of symmetry, then plug in your x value to find your y value to get the ordered pair for your vertex. So here I've got an application problem for you. The graph of f of x is negative, that's a negative sign there, 0.06 x squared plus 0.6x plus 10.26, and that equation is used to model the height in meters of an arch support for a bridge. So the x-axis represents the water level, so this is the water level, and x represents the distance in meters from where each arch support enters the water. And I want to know if a sailboat that is 14 meters tall can pass under this bridge. Well, how would I find that? Well, if you look at this bridge, that bridge looks exactly like a parabola, and I'm looking to see if this vertex is at a allows for a sailboat of 14 meters to pass through it. So if this is my x-axis, I need to see if my y value of my vertex is at least 14 meters. So of course I'm going to solve for that. So I find my axis of symmetry first. X equals negative b, or 0.6, over 2a, so 2 times negative 0.06. So my x equals 5. And then I'm going to plug in my x value to find my y. Negative 0.06 times 5 squared, or 25, plus 0.6 times 5, plus 10.26. So my y value is 11.76. So notice that if my sailboat mast of 14 feet attempted to go under this bridge, we would definitely be in trouble because this is only 11.76 meters high. So I'll expect you to bring these problems solved to class tomorrow. But in the meantime, what you've all been waiting for, the joke of the day. So a talking sheepdog gets all the sheep in the pen for his farmers. He comes back and tells the farmer, "All right, farmer, all 40 sheep accounted for." The farmer turns to the sheepdog and says, "I've only got 36. The sheepdog replies, "I know, but I rounded them up." All right, I will see you guys tomorrow with these problems done.